we're doing a little review for our 6 weeks test. Right now we're going to learn how to solve this rational equation. You'll notice in the denominator we've got a y plus 2, we've got a y, and we've got another y plus 2. Well, the problem that we have here is we have a whole bunch of y's in the denominator that we need to get rid of. So my suggestion for everybody is to multiply the whole equation by a y and a y plus 2. These two factors are what's considered to be this thing called your least common multiple that you're going to have to take and distribute to every single number that is in the numerator. So I'm going to distribute this to every single number, and I will do it as quickly as I can. You can feel free to pause this if you need to catch up. And voila! What I've done right now is I've multiplied y and y plus 2 to the 2, to the 3, and to the negative y. You'll notice those factors are right next to each other, all in the numerator. All right, if you need to pause to be able to write those down, you can certainly pause me whenever you feel like it. Or if you want to mute me, do that as well. All right? Tori, sometimes you like to mute me in class, don't you? No? Oh. Now, why did I multiply everything by a y and a y plus 2? What's going to cancel out here? I'm going to do it in red and make it bleed. The y plus 2s, I like it. Yes, the y plus 2s will cancel out. What's going to cancel out here? The y's, they cancel out. What's going to cancel out here? The y plus 2s. The whole reason we did this is so that we could get rid of all those ugly y's in the denominator. All right? So what do we have left now?
2y.
We have 2y plus
3y plus 2.
But notice, I'm making sure I keep it in parentheses, Ryan, so eventually I can distribute. Now this is where students sometimes pause. They're like, I've got a negative y and a positive y, and I'm multiplying them together, not adding them. Nope.
Negative y squared?
Yes. Negative y squared. A negative y times a y is a negative y squared. So here's what we have left. I've got a 2y. I'm going to distribute the 3 to both numbers. Now I realize something. That little 2 right there as an exponent lets me know I am dealing with a quadratic equation. And quadratic equations need to be set equal to what number? 0. So we're going to combine these 2y's and 3y's and make a total of 5y's. So, no, it's going. It's going. Yeah, it's been going. All right. Yeah, it's going right there. Now, if I want to move this across, all right, what's going to happen? I basically have to add y squared to both sides. And here's my quadratic equation right there. There's my quadratic equation. Now, there are multiple ways to solve for a quadratic equation. Some ways are easier for me than others. Okay? If you look at this and you're like, what's the first thing that pops to your head? I'll pause it real quick and see what people come. So obviously you can use the quadratic formula if you wanted to. Right now, A is 1, B is 5, and C is 6, and you can plug it in and you can get 2 of your answers. All right? Obviously you can use the graphing calculator, hit y equals, and right now there's my equation right there. You can type it in. Now, what did I change? I changed all of the y's to x's, okay? Because when it says y equals, we got to use x values here. If you hit graph, there's your graph right there. What are we looking for in this particular graph, everybody? Where it crosses the x-axis, and we cross the x-axis right here and right here at a -3 and a -2. So what are my 2 answers? -3 and -2. Now, if you didn't know that, you can check your table. Go to your table. And you can look at your table, and what do you look for? You look for where y is equal to a 0. In the quadratic equation, you look for where the y value is equal to a 0, where it crosses the x-axis. Now, somebody out there is watching this video and saying, you idiot, why didn't you just factor it? That's the easiest way. And I agree, that is the easiest way. If I were to do this, I would factor this into y plus 2 and y plus 3 equals 0. And how did I factor that so quickly? Because 2 plus 3 equals 5, and 2 times 3 equals 6, and those are the patterns when you're trying to factor trinomials where your a value is equal to a 1. Now, by the way, what number could I plug in here to make it equal to a 0? -2. What number could I plug in here to make it equal to 0? -3. That's why my solution set is a -3 and a -2. But wait, there's more. Because sometimes you're going to get answers that are considered to be extraneous. What are extraneous solutions? Answers that you get that don't work. Scroll back up. What number would be bad to plug in there? -2. But what happens to the denominator? It makes it equal to 0. And are we allowed to have 0 in the denominator in the real world?
No.
So, what answer am I going to eliminate that's extraneous? I'm going to say -2, you won't work. So my final answer, everybody, is just a -3. That's my final answer. Right there. All right, moving on, we're going to go to problem number 2, right here. Oh, man, we've got a 3m. We've got a 3m and we have a 4m, and I want to eliminate all the m's. So I have to find what's known as the least common multiple between a 3m and a 4m. Ryan, you think you got it?
Yes.
What do you think?
12.
Close.
9.
No. 12 is right. 12.
Yeah.
M. Very good. So listen, everybody, what I want you to do is I want you guys to multiply everything that you see by a 12m, because the least common multiple between a 3 and a 4, Ryan, is 12. But the least common multiple between an m, and an m is an m. That's why it's 12m. So you're going to take this, everybody, and you're going to multiply it to every single number or expression in the numerator. Now, I'm going to pause it and get it all written out, and you guys can pause the video if you need to. So you'll notice on the screen, it really happened quickly, almost like magic. I took 12m and multiplied it to 1 and got 12m. I took 12m, multiplied it to 6m minus 9, and there are the two factors right there. And then 12m times 3m minus 3, you'll see right there, everything's in the numerator. Now, the reason why I did this is to get rid of all of the m's in the denominator. Let's make it bleed. 3m goes into 12m 4 times. So we have a 4. 3m goes into 12m 4 times. So we have 4 times 6m minus 9 equals 4m goes into 12m 3 times. And we have 3 times 3m minus 3. So you'll notice all of the m's and the numbers that were in the denominator are now gone. All right, now, at this point, we basically have an Algebra 1 problem at this point. All right, all we have to do is distribute all the way across.
24m minus 36
Good.
equals 6. Oh, and 9m minus 9.
There we go. Now, all we have to do is solve for m. Over here, I'm going to clean it up. I'm going to take the 4 and I'm going to add it to the -36. And that's going to get me a -32. So all I did was just combine the 4 and the -36 to get the -32. Now I'm going to solve for my m variable by adding 32 to both sides and by subtracting 9m from both sides. Here, I'm left with a 15 times an m. That zeroes out, that zeroes out. These are additive inverses of each other. 32 minus 9 is a 23. So I have 15m equals 23. And I have to divide both sides by 15. And m equals 23 over 15. So my solution set is simply 23 over 15. I much prefer an improper fraction to a ridiculously long decimal that has no end.
How the same thing using 3m and 4m?
All right, so there's your final answer. And now we have the first two questions done.